Let's look at multi-threading in Java. Before going to discuss about multi-threading, we should know what is multitasking, how can we achieve multitasking, what is a thread, how to create multiple threads in Java, and what is the life cycle of thread, and of course other topics. Let me start with what is multitasking. Multitasking is the concept where multiple tasks can be done simultaneously on a system which should use 100% CPU cycles. To effectively utilize the resources, we are going to do multiple tasks simultaneously. That is what we call multitasking. This multitasking can be achieved at two levels. One is at process level and another one is at thread level. Let's look at process-based multi-threading, process-based multitasking. Process-based multitasking, the best example is you take any operating system. Probably when you run multiple programs, that operating system is capable of doing multiple tasks simultaneously. Best example is this. Now I am playing a video, I am playing a presentation, I am playing something called a recording software, I am playing some other tools like notepad, command prompt. All these programs are running simultaneously. If you see the processes, in the list of processes, maybe you find this in task manager. Yeah, these are all the processes that we are running, right? There is an Acrobat Reader application running, Cam Studio recording software is running, Notepad is running, Task Manager is running, Command Prompt is running, Windows Explorer is running, right? So this is what we call process based multitasking. We are using the resources of this particular CPU by running multiple programs. Okay. So another way, another approach or another way of implementing multitasking is thread level. When I say thread level or thread based, we should know what is a thread. In fact, thread is a lightweight process, or we can say part of process. Or in another way we can say a thread is a single sequential flow of control within a program, or it's a part of the program, or it's a smallest unit of dispatchable code. Like this we can say in different ways about the thread, right? So when you run any program, we are going to create multiple threads, or we are going to run multiple smallest units or multiple threads that execute the process simultaneously, and of course it uses 100% CPU cycles, right? So best example is this. When you see any online application, right? So at a specific moment there are millions of users running their application. That time maybe at server level only one single program is going to handle the millions of people or millions of requests being generated by people. So that time, to handle the request of individuals, that process is going to create a thread. That thread is responsible for handling a particular user, right? That is what we call multi-threading. A process is actually a heavy weighted task, whereas thread is a lightweight task. As I said, thread is a part of the process, and every process has their own space, or it requires in its own address space, whereas thread doesn't require any special space. Maybe the thread is actually using the space which is already created for a process. Inter-process communication is expensive in the case of process-to-process communication, but not in the case of a thread. As well as context switching means that switching from one process to other process is difficult or in the costlier in the case of process based, whereas in the case of thread it is not costlier, it is cheap, right? Multi-threading enables programs to have more than one execution path, and of course these execution paths runs concurrently or simultaneously. Each path of execution we call it as a thread, right? So using these different threads, we are going to utilize the CPU cycles and minimize idle time of the CPU. That's the benefit, or that's the intention behind the multi-threading concept. Every thread has different states, right? When I say thread fall in different states, and of course thread has its own life cycle. Okay, the first state we can say it as born state or new state. When a thread is created, that time the thread comes into a state called new state or start state or born state. When it born, probably it drops into runnable state. Runnable state in the sense the thread is being executed. Thread is in execution, and sometime the thread goes to non-runnable state. This non-runnable state could be anything like waiting state, timed waiting, or a blocked state. And another state we can say it as a terminate state. Terminate state means thread execution stop at this particular stage. So if you see the life cycle, once it born, probably it goes to new state, and new state to runnable state, or it may go directly to terminate state. From runnable to non-runnable, it may go and come any number of times. Okay, once it goes terminated state, definitely it will stop, it will die. To create a thread, we have two ways to do. One is we can extend thread class, or we can implement runnable interface. Okay, so let me write a simple program where it talks about creating a thread. When I say class test extends thread, so it's a thread class, or we can say implements runnable interface. Yeah, here we can say test or demo thread. Thread space t and string space msg, string msg, and this dot message equal to message, and t equal to new thread of this comma, let's say msg, then t dot start off. Of course it invoke runoff method, public void runoff method. Here I am going to print first 10 natural numbers, int I equal to 0, I less than 10, I plus plus. And here I try to keep this and of course we keep this thread in a waiting state for, let's say, 200 milliseconds. Yeah, so now let me write a class demo thread program, public static void main string args, and we have to create the object of this demo thread. Demo thread t1 equal to or ob1 equal to new demo thread of 1. Let's say 2. Okay, yeah, and of course try. The main thread will close only after successful completion of the child threads. So that's why I keep this main thread. Here we have a main thread to run this main method now. So this thread should be in a waiting state about 1000 milliseconds. Yeah, let me run this. Yeah, so here is a simple example which talks about creating multiple threads.